Oh, hello everyone. Welcome to our presentation from blinking LED to interactive art, scaffolding the path to digital fabrication education. Our abstract is down below. If you would like to read that, you can. Otherwise, my name is Alyssa Woods, and I am the Fab Lab specialist here at the Gregory School. And my specialties include digital fabrication, interactive art, and just simply merging art and technology together into one. And here's my colleague. I'll let him introduce himself.
I'm Dennis Connor. I've been doing kind of this Fab Lab education for the past 10 years, but in love with maker education for much longer than that, and really just enjoy being in the space that and teaching in the space that we are in.
Yeah. So who are we? As previously mentioned, we are the Gregory School Fab Lab in Tucson, Arizona. We are a private school, 5 through 12, and we are able to teach the students through a special activity on some Fridays that we call explorations. And we have that today as well. And explorations are basically a time where the students can choose which classes that they want to attend on Fridays. So for the Fab Lab, what that looks like is for on our middle school side, we like to introduce them to 3D printing, laser cutting, all of those different tools. So we have intro to 3D printing. We have jewelry making this morning where it's simple and we teach them how to use Tinkercad and our laser cutting softwares. And on our classroom side of things, so like the other 80% of the time roughly that we have in school, we have different classes that come into the Fab Lab. We have engineering, digital design, entrepreneurship, as well as a project-driven class called Design and Build, where the students can come in with an idea and they spend the semester trying to make that idea become reality. And so now we'll talk about our core focus.
So our goal has been to do a number of different things here as far as we have these workshop classes, we have these traditional classes, but we are constantly thinking about access and how we can get more students in and keep students in for a much longer time. One of the problems we have, and hopefully we have time at the end to hear maybe if you all have similar types of problems, is that there is a large amount of curriculum that can kind of come up front, that you're spending a lot of time teaching, very traditional things from very basic 3D printing to maybe some basic electronics. All of these skills, take time and they take coursework, and you're trying to also appeal to an entire school set. So that long pathway, that traditional scaffolding, where you build basic skills and then grow on those skills and then finally get in your later years to those advanced projects, sometimes leads us rethinking how we should be doing our education and practice, because what we want is the students to see those end goals and start participating them, jumping into that experience very early, and then trying to learn the skills that they need in order to accomplish those. So we're constantly reading about how we shape our classes, our exploration time, in order to make sure that students are getting that experience, and that may drive them and keep them in kind of our realm of education a little bit better. So one of the things that we have is that we really put a lot of time in our exploration time, in our workshop time, is with our digital design, because it's a course that has a wide audience and it has lots of different kind of tools that we can kind of utilize.
So first we're going to talk about what is interactive art. And interactive art is where the observer becomes a part of the experience and it changes the art and the perception of the art in general. And this is by using sensors, physical interaction, play, or just whatever the artist intends for you to react to. So in the Fab Lab, interactive art lowers the barrier to entry. So we have a mixed group. We have artists that come in, and then engineers that come in. And so for interactive art, we like to see the artists start to feel more at home in the Fab Lab. And even if they're spending 80% of the time just creating an art piece and then 20% of the time coding, wiring, learning about Arduino, then they are spending 20% of that time learning something that they didn't know before. And so that is very valuable. And then they're working from the ground up in that sort of way. So our entry points to interactive art here in the lab, first is Arduino. I'm sure most of you know what an Arduino is. It's a microcontroller, and you can plug in lights, sensors, motors, different components into projects in order to get them to work. Here are some examples of some things that I've made. A lot of interactive art projects are very special to the creator, and so they like to take those home. But Arduino is very fun because there is a lot of documentation online. So if the student needs help and if they are struggling to learn something, then there are multiple YouTube videos and examples online that they can uh, reach out to and sort of learn from there. And then we also have Touch Designer, which is a node-based software. So it's drag and drop, which makes it very beginner friendly. And at the lower photo there with the red, you see the Red Hot Chili Peppers. That is a band, and they use Touch Designer in their concert in order to create an immersive experience with their fans. And good thing about Touch Designer, you put something down, it doesn't look good, you see previews at every step, and so you can delete it, try again, try something else. And then next, we have P5.js and just creative coding in general. So what I like to use, well, P5.js, first of all, is an open source JavaScript library that the students can code interactive art and create visuals sort of through this online platform. And what I like to use is a website called Open Processing, and they have a number of different examples out on their website. And so it's easy for the kids to go in, choose an example they like, and just play around with the values. So the first thing, I mean, especially with middle school kids and even high school, they don't have a lot of coding experience. So they don't know what variables are or what they are supposed to do. And so what I like to say is just change the numbers, see how they edit the final art piece, and then eventually they'll get bored of just changing numbers and they'll start adding their own variables and their own interactions. And P5.js is pretty simple, and so it would be easy to do that overall. And so one of my favorite examples of interactive art is Meow Wolf. It is an immersive and interactive art experience, and it uses large-scale exhibits to engage its visitors. So it's located in several cities across the United States, and it's often seen as the pinnacle of interactive art here. I had the chance of visiting the one in Denver, Colorado. They set you up with a card, you go around and you tap that card in various different places and it changes your environment. You're able to change the colors of the alien bulbs on the right-hand side. So I took a picture while it was blue, but you tap the card and it turns red. Or there was a room where you can spin a ball and it makes it look like you're in a planetarium. And they also use Touch Designer a lot in this exhibit. The picture on the left is what you can see there, but it is very fun and it combines storytelling, art, engineering, design in order to create something truly unique. And we like to say that, or we like to encourage the students to dream big. They don't have to dream necessarily this big, but we like to encourage them to dream big so that we can invite them to test their limits and they can learn the finer skills along the way.
So our goal has been to give them these little moments of inspiration, but there's a number of ways that we have to continue to work to engage our students in order to help them through this process. So a lot of times we're asking them to jump into these bigger bigger experiments, bigger projects, and we want to give them a little bit of at least grounding, a little bit of a platform to build from. So one of the things that we sometimes do in some of our classes or some of the workshops is this shifting the student role a little bit. So the example on the left here is an example from our entrepreneurship class. They were asked to create a multi-tool following an example that we took from the book by Tina Seelig on being creative. They're learning to be creative, they're learning to design, but not every student in that class has the skill sets to go in and 3D model. So for some of those classes, some of those groups that did not have someone on hand who had built up the experience in order to do their own modeling, my colleague and I just jumped in and told them, hey, we will be your interior designer for this. I need you to come with a certain expectation. You're going to come with some drawings, maybe some AI art, and you're going to sit beside me and you're going to tell me how to change parameters. And we're going to go through these and we're going to go through an iterative process together. So by shifting that student role from expecting them to do the whole process to giving them a little bit of place to build that skill set, most of the time, when they're done with the project, they're often telling us, I wish I had more experience in the Fab Lab so that I could take this further. The far example on the right is actually from one of the interactive art classes. The student made this really neat interactive firefly. We didn't ask her to model it. We took the model from online. It's bookmarked at the end if you want to see where that's at. And what we did was we taught her how to kind of take it apart, to use CAD programs to split and divide, and just kind of talk through the process of what she wanted, so that she could make the experience, the storytelling aspect. She ended up kind of coming in here, putting in some simple LEDs and basically programming blink. But with that, it was a much different experience because she had it in her interactive art exhibit. We're often talking about, number of ways to get students kind of thinking about long-term projects. Another tool I use with workshops, with my classes, is actually just pointing them to a number of YouTubers, the high-end, high-impact engineering YouTube videos that are out there today can very quickly get students in an ideation mode, get them going into creating. And this allows us to kind of plan across multiple capabilities. So students who want to come in with a beginner might do a project here done by Veritasium and Mark Rober. And in that project, they're using compliant mechanisms, 3D printed models that are easy to manipulate, that actually have motion and movement to them, but those have a number of applications. So for some students, they're 3D printing and learning how the material properties work and maybe making small changes. Other students at the same time are trying to turn those compliant mechanisms into a game. So it's that multiple platform within the same environment that allows the kind of students to learn. But I like having the high impact videos up front because those provide the inspiration and tools to drive. So I've done math projects where it's more like Veritasium has this great one on tiling and Pinrose tiles. And there's Mark Rober is an excellent example of just making engineering fun. And so I've had students take one of his examples of hacking an arcade experience and kind of coming in and building devices that push buttons for you as if you were in an arcade, and just giving them that little first video teaser, not giving them instructions, not telling them how to do it, but telling them what the outcome might look like and give them the creativity to grow that idea. It's part of kind of this idea of giving a multi-platform, a multi-place for multiple users to kind of come in and use the space. All right. We're doing a number of things, just a quick number of ways that we want to continue having students set goals for themselves, come in and gather their own resources and do their design work. In other words, we want them in charge of their own process. So we are constantly looking for ways in which we can actually make this happen. We want to give them the right environment to do that. And we want to give them the help that they need. But at the same time, we're looking for student agency and student goal setting. This is just one more example here. Our goal is to foster this independence. This is a student who wanted to do on her own an interactive art project. So we had her design a clock for the lab. She had not actually done coding before. We kind of relaxed that by telling her, here's how vibe coding works with AI, how you can program even an Arduino. She caught on to that very quickly. She was able to put together the electronics just in time, all of the knowledge that she needed to. She made this clock with this beautiful rainbow animation that kind of slowly scrolls across throughout the class period. And, it's there, it's in front of everybody. It has a number of different attributes that she's looking to improve on in the future. But what, really is for us is not only inspirational for other students coming in, but it also, for her, was this first little, maybe I want to learn how to code a little bit more, because while she had fun doing it with quickly and getting the project up and getting it in front of everyone, she really wanted the control of being able to fix the little things that we had to fix for her at times. All right. Well, what we wanted to hear we have a number of other ideas, but we were hoping to hear a little bit from you all about maybe anything in this same realm of experiences, or take a couple of questions because we have a few minutes left, I think.
Hi, this is
Yes, we have
Glenn
4
Ball.
minutes, so go ahead.
This is Glenn Ball, and I wondered if you thought any of the information that John Maloney talked about this morning had any relevance to your work.
I do. I mean, we play with the microbits all the time. It's the way in which he kind of tinkers is very much the way that we want to tinker, right? Um, I sometimes hate being locked into one platform, and often students feel like that's the only thing that once you teach them a platform that they're just going to keep using that platform. We sometimes like them to come with an idea and then help match them and help them find the right tools to kind of fill out their big goals. So that's why things like interactive art can provide, sometimes it might be a microbit, sometimes it might be an ESP32 if they need a Wi-Fi capability. So being adept at kind of letting them find that platform and forcing them into those is great.
Well, I was thinking more about using things like Snap and microblocks rather than the specific.
Oh,
You know, I mean, his system supports several dozen microprocessors, so it doesn't lock you into particular one. But we've been able to get kids up and going faster using some of John's his. As you know, he was the lead developer for Scratch and subsequently Snap, which is taught at, the University of California at Berkeley, and about 1,000 K-12 computer science teachers. And what we like is that the microblocks work so well with things like Snap, and it
mhm.
lets us get kids up and going before we start working with things like JavaScript or whatever. And I just didn't know whether that had any place in the way which, by the way, let me say what you're doing is fabulous. And I think a lot of people wish that they could be in a school like the one you have doing that kind of project. But I just wondered in sort of your cognitive map if there's a fit for things like Snap and microblocks and things like that.
I think there is, like John mentioned earlier today about how much sometimes there's pressure to move on to those text-based languages. I'm probably a person who sometimes does that with students, and I feel bad, and I'm like, I need to, let them develop the skills better when this is sometimes what they want to do, right?
But we absolutely think art and music and that type of thing is the way to go. You've got it's much more broadly appealing than more
Yes.
narrow topics. And the work you're doing is inspirational.
Well, thank you. We definitely know that we're kind of fortunate to have the work schedule and the flexibility to kind of provide some of that independence.